Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
In this lecture, we are introducing our upcoming project, Build a Simple Tally Decentralized Website with Truffle Solidity and Vanilla JavaScript. Our first step is going to be to build a Truffle project. Then we're going to build a custom Solidity smart contract. In the smart contract, we are going to have a count that you can increase or decrease. Then we're going to compile our contracts, which will generate the contract ABI. A contract ABI is the application binary interface, similar to an API, an application programming interface. The ABI defines the methods and structures used to interact with the binary contract. ABI encoding indicates the caller of the function to encode the needed information like a function's signature and variables. This encoding is encoded into a format that the EVM can understand to call the function in bytecode. The EVM is the Ethereum virtual machine, the core component of the Ethereum network. A smart contract is just code that is stored on the Ethereum blockchain, and the code is executed on the EVM. A smart contract is usually written in a high-level language like Solidity or Viper. And these high-level languages need to be compiled into EVM executable bytecode because the EVM doesn't understand Solidity, it only understands bytecode. So we compile a smart contract into this bytecode, and the smart contract is just now bytecode. Then when the smart contract is deployed, the bytecode is stored on the blockchain, and the contract is associated with an address. To access functions and variables from the Solidity contract, we must translate names and arguments into byte representations. To get an API, commonly you'll use Truffle compile. If you're not using Truffle, you can also compile a contract with Remix or with Solidity compiler, which is a command line tool, or you can use another tool like Hardhat and more. Next, after compiling the contracts, we will deploy them. So we'll have to build a script, and then we can migrate the contracts, which means you actually put the contract onto the blockchain. Then we will build the client side for the project. So we will build the front end, meaning the website. And then anyone can go to the website and they can interact with our smart contract via the website. We're going to be using Ethers.js, which is a tool that allows us to work with the Ethereum blockchain in JavaScript. We're also going to be using a CDN to get Ethers.js, which is just a way that you can load in a library via the internet into a project, because our project is not going to need NPM or Node. Instead, we'll just use a CDN. This is a preview of what the HTML file will look like. It'll be quite simple. Then we'll build a JavaScript file to connect to our Ethereum blockchain on the website. And our clients will be able to interact with the website via Metamask. So when they press a button, they can then use Metamask to perform some kind of transaction on the blockchain. And therefore, they can interact with our smart contract. So overall, they're interacting with the contract by going to the website and also by using Metamask, because Metamask allows you to have cryptocurrency and to connect to a network, so you can actually interact with the Ethereum blockchain on that website. Otherwise, you're just visiting a regular website. You need the extra layer of Metamask to be able to interact with Web3. We're going to show how a user can visit the website and use Metamask to increase and decrease the tally. And they're not just increasing a tally on their own client side. They're actually changing the smart contract. They're actually interacting with the blockchain. Now, to see this in action, we will have to use a server to run our website. That way we can bypass the cross-origin policy. We'll use HTTP server, which is a super easy way to run a website on a web server. You can use other options for servers as well, but you'll love HTTP server because it's so easy. There's no configuration and it's just one line in the command line to start a static HTTP server. This tool is powerful enough for production, but also simple enough for local development and learning. And we'll show you how you can get HTTP server very easily. So we'll start the server and then we will open Ganache, which allows you to have a local blockchain. You must have a local blockchain running if you want to interact with a local network. You can also run this project on other networks, but you do have to configure the project for whatever network you want to run it on. We'll then sign into Metamask using our Ganache mnemonic and connect to the local network. And then we'll be able to see our website in action. And we'll also give you some tips for debugging your website, how to solve errors, and how to understand what's happening throughout the whole process of going to the website, connecting with MetaMask, interacting with the contract, and seeing the changes. So it's a very fun project, great for beginners, and it's simple on the front end side because we're not using any framework like React. We're just using an HTML file and a JavaScript file for the client side, so keeping that simple. And then the smart contract is also simple and straightforward, and we're going to explain each step: building, compiling, migrating, and running. All of that we'll explain step by step, taking you through the whole process of building a decentralized app, a decentralized website from scratch. So join me in our next section where we'll get started. Hello everyone and welcome back to our course. Before we build our Truffle project, let's discuss what is Truffle Ethereum. Truffle is for the smooth and seamless development of decentralized apps, also known as dApps or D-apps. With Truffle, you can deploy smart contracts, build web applications and websites, and run tests and more. You can compile and deploy their contracts and inject them into a web application. Therefore, it's helpful for building out the front end or the user-facing side for your decentralized app. You can build out smart contracts with Solidity, and then you can have an interface so that people can actually visit a website and use your service, whatever kind of decentralized app you have, whether you have a store or a voting system or a game. With Truffle abstracts away many Web3 and Ethereum complexities because it can be difficult to build a blockchain app, and Truffle really simplifies the process. Truffle is the most popular tool for blockchain application development. And that's an introduction to Truffle. So join me. Coming up next, we are going to build a Truffle project. So we'll learn how we can install Truffle with NPM and create a Truffle project within an NPM project. Hello everyone and welcome back to our course. Previously, we built an index HTML file, and coming up next, we're going to build our app and load Web3JS. So first, let's discuss what is Web3JS and why do we need it in our project. Web3JS is an Ethereum JavaScript API, application programming interface. It is a collection of libraries that allow you to interact with a local or remote Ethereum node with HTTP, IPC, or WebSockets. Web3JS is the main JavaScript library for interacting with the Ethereum blockchain. With Web3JS, you can do a whole range of tasks like sending Ether to one account from your account, reading and writing data from smart contracts. You can build smart contracts and more. Using Web3JS is similar to reading and writing data from a web server. If you've ever done any web development using a server, then you'll be familiar with this concept, where a client visits your website and maybe they fill out a form. Then when they hit submit on the form, the data from the form gets sent to your web server. That way you can store that data perhaps in a user profile. And this is a similar concept, Web3JS. Using Web3JS to read and write to the Ethereum blockchain is similar to using a tool like jQuery or similar to read and write data to and from a web server. Web3JS allows us to make requests to an individual Ethereum node using JSON RPC to read and write data to the network. To read more about Web3JS, you can go to its official documentation. For now, that's all you need to know about Web3JS, because coming up, we're going to actually take a look at how Web3JS is used in our project. So join me in our next lecture. Hello everyone, and welcome back to our course. In our previous lecture, we learned how to run our project. Coming up after this lecture, we're going to learn how to load blockchain data. Now, in order to test our project, our decentralized app on the web, we need to install Metamask. So in this lecture, we're talking about what is Metamask and how do we install it. Metamask is the #1 software cryptocurrency wallet used to interact with the Ethereum blockchain. It allows you to access your Ethereum wallet, and it comes as a browser extension or a mobile app, and it's free. With Metamask, you can interact with decentralized applications. You can use your Ether, whether it's your real Ether or your test Ether, to make transactions and to perform tasks. You can buy, store, send, and swap tokens. Metamask provides you with a key vault, a secure login, a token wallet, token exchange, and more. Everything you need to manage digital assets. Metamask is extremely popular. It's the simplest yet most secure way to connect to blockchain-based applications. The creators of Truffle and Ganache also created Metamask. Metamask is also secure because it will generate the passwords and keys on your device, not on any shared server. So only your device has access to your accounts and data. You can download Metamask by going to metamask.io/download. And we are going to be using the Metamask browser extension in order to test out our decentralized web app. Currently, the supported browsers are Edge, Brave, Firefox, and Chrome. We're using Firefox in this course, but you can use any of the supported browsers. And in the future, Metamask will likely support more browsers. So make sure to go to Metamask's official site and get the browser extension for Metamask. Then join me in our next lecture. We are going to learn how we can load blockchain data and use Metamask. Hello everyone, and welcome back to our course. To deploy our smart contract on a blockchain, we need a blockchain network. To get a personal Ethereum blockchain network, we'll be using the application Ganache. So let's talk about what is Ganache and how to install it. Ganache is a personal Ethereum blockchain used for testing your smart contracts, executing commands, and inspecting state. You can deploy your smart contracts on a Ganache blockchain before you deploy on a real blockchain, on a public blockchain. Because with Ganache, you can do testing and development for free. You can test transactions and deployment completely for free. Ganache provides test accounts, test wallets, test Ethereum, ETH coins, a network, a custom local remote procedure call for a request response protocol that you can hook up to Metamask, which we'll look up later, and more. You can download Ganache at trufflesuite.com/Ganache. It works on Mac, Windows, or Linux. And with Ganache, just note that you have to have it open whenever you want to access that blockchain. If you want to make a transaction on your decentralized web app, or you want to deploy a contract on your network, you have to have Ganache open if you are going to be using this network via Ganache. If you don't have it open, you'll get an error message thrown. And that is an introduction to Ganache. So join me in our next lecture where we will put to use Ganache. So make sure to install Ganache and then join me in the next lecture. Hello everyone, and welcome back. In this lecture, we are beginning our project of building a simple tally dApp with Truffle Solidity and vanilla JavaScript. Our first step is going to be to build a Truffle project. So join me in your terminal or command line application. Here we're going to create a new folder called Hello Tally. Then we're going to enter the folder. In this folder, we're going to call Truffle init to initialize a new Truffle project. Here the init is successful and we have some prompts here to scaffold a contract or scaffold a test. Let's open up our project with a code editor. When you create a new Truffle project, you get 3 folders: a contracts folder, a migrations folder, and a test folder. Inside of contracts, you have a sample Solidity contract called migrations. Inside of the migrations folder, you have a sample script called initialmigration.js. You also have a test folder with nothing inside except a git keep. And you have a Truffle configuration file, which is where you can configure your Truffle project. This is similar to configuring a node project. We're using Solidity version 0.8.10 in this project. You can use a different version of Solidity, but just note that there might be a breaking change that you might have to change the code that you write if you're using a different version of Solidity. Our next step is going to be to write a Solidity smart contract. So let's get started. We're going to create a new file inside of our contracts folder, and let's call this contract tally.solidity. So this is the file name, and it's typically best practice to have the file name be the same as your contract name. So if we have a contract called tally, we want the file name to be the same. At the top, we should also include our license, because this is the standard for smart contracts, and you will be prompted to include a license if you don't. So let's set the license of this file to MIT. And just make sure that you spell identifier correct there. This is the SPDX license identifier. Then we'll specify the Solidity version, Pragma Solidity. We're going to use any versions including or higher than 0.8.10. Okay, so that will allow us to use that version or higher of Solidity in this contract. Now in this contract, let's create an event called count. This is going to emit to increase or decrease the value of our current tally. In here, I'm going to pass in a method, a count, and an address. And I'm going to create a public integer called count. We are going to keep track of this count, and we'll be able to increase or decrease the count. Anyone who visits the website will be able to increase or decrease the count, but they will have to do that via a transaction, so we'll need to grab their address. We are going to have one function called increase, which will be public, to increase the value of count, so you can just increase it with the ++ operator. Then we'll also emit a count event, which is going to say increase, count, and message.sender, so we'll have some data being emitted. We'll also have a similar function called decrease, but this one is going to decrease the value of count. So we just have to take count and subtract it. Then we're going to emit another count event that says decrease with message.sender. Awesome. One more thing that we need is a function to get the count. So I'm going to build a function called getCount, which will be a public view and returns a uint. So that way we can access the count via a function should we want to make the count private. And that is all we need for our Solidity smart contract. Next up, we have to compile our contract and deploy it, and as well migrate it. So to compile this contract, we're going to go into our terminal or command line. Make sure you are inside of your project folder, and then call the command truffle compile. This is going to compile all of your contracts, which we have migrations.solidity and tally.solidity. The artifacts will be written to your project folder /build/contracts. Then you'll see the Solidity compiler that was used. So now you'll have a new folder in your project called build, and then a subfolder called contracts. There you have JSON files for each of your contracts. So we have one for migrations and one for tally. This is just converting your Solidity contract to a JSON format. So that way you can now use your contract in a front end, like in a website, because you have it in the JSON format. Here you can also get the contract ABI, which is just one of the keys in this JSON data. Coming up next, we're going to deploy and migrate our contracts. So join me in the next lecture. In this lecture, we are going to deploy and migrate our custom smart contract that we wrote in Solidity in a Truffle project. Our first step will be to deploy the contract. So we will need to build a script to deploy our smart contract. Scripts go into the migrations folder in your Truffle project. We already have one file called initial migration. This file right here, this deploys the migrations contract. And we need to build a very similar file to deploy our custom smart contract. So we can just copy all this code and then inside of the migrations folder, create a new file called to_deploy contracts.js. Note that this is a JavaScript file. In here, we're going to just paste the code from initial migration, but replace migrations with tally everywhere that it appears. So what this means is we are requiring from our artifacts the tally JSON file. The artifacts is just the JSON data of your smart contract. Then we are exporting our deployer, which uses the deploy function on the tally smart contract. So here we are deploying our custom smart contract, which we called tally. Then save that JavaScript file, and now we can deploy this contract. So how do we actually execute this file? Well, we're going to go into the terminal or command line application. Here, go to your project folder and call the command truffle migrate. This is going to migrate your files. So let's take a look at what happened because we get a lot of notices here appearing in the terminal. First, we see compiling your contracts. Everything is up to date. There is nothing to compile. So when you call truffle migrate, this actually first compiles your contracts, which means you don't actually have to call truffle compile manually. You can just do it all in one right here in truffle migrate. Everything is up to date. There is nothing to compile because we already compiled our smart contracts before with truffle compile. Then we have this message starting migrations. The network name is Ganache, the network ID is 5777, and the block gas limit is this value. So by default, the network that will be used is Ganache. Then we have our first script being run called initial migration. This deploys the smart contract called migrations. And for each of the deployments, we get a bunch of information. We get the transaction hash, the blocks, the seconds, the contract address, the block number, the block timestamp, the account, the balance of the account, the gas used, the gas price, the value sent, and the total cost. You may be wondering, where does this account come from? Well, if you open up your Ganache, you can actually see that account is the first account in your Ganache running. So you can either use the Ganache desktop application or the Ganache command line application, where you can get these accounts that each have an address and they have test ether. So this is not real ether, this is just test ether for you to use when you're testing out your projects, which we are now. So make sure when you are migrating your contracts that you do have Ganache open. Otherwise, you won't be able to get this deployment. So we get our account, the account balance, the gas used, the gas price of the transaction, the value sent, and the total cost. Then we save the migration to the blockchain and we save the artifacts and we have the total cost. Next, we run our second script, which is deploy contracts.js. We are deploying tally and we get all the same information, but this time about our second smart contract. And finally, we get a summary of the total deployments, which was 2, and the final cost. Now, what if I close Ganache? I quit that desktop application. This tells me I no longer have my local network running. I no longer have the local blockchain running. If I call Truffle migrate this time, let's see what happens. So this time you'll get a message that says something went wrong when attempting to connect to your network at localhost port 7545. We could not connect to your Ethereum client with the following parameters. Check that your Ethereum client is running, is accepting RPC connections, is accessible over the network, and is properly configured in your Truffle configuration file. Okay, let's go through all of these. When you migrate your contracts, Truffle is going to connect to a network. It's going to connect by default to the local host at port 7545, which is the port of Ganache. So if you don't have Ganache open, you'll get this message that says we could not connect to the network because it's not open, it's not running. That's why you have to have it open, or you get this message. You don't have to connect to Ganache, you can connect to a different network, but you have to connect to some kind of network. So in this case, the default parameters that Truffle uses are these parameters: localhost at this port with this network ID. This is for Ganache, and that's the default. Currently, our Ganache is not running, so that's why we get this message that we need to check that the Ethereum client Ganache is running. You can also use a different network, but you have to make sure that you configure that network in your Truffle configuration file, truffleconfig.js. So yes, you can use a different network. You could use mainnet, you could use Robston, Rinkeby, but you have to configure that network if you want to use it. If you want to just use the default, which is Ganache, then just open Ganache. You can either launch the desktop application of Ganache or the command line application of Ganache, but you have to have it running. You have to have the command line Ganache instance running or the desktop Ganache instance running. You have to click here, Quick Start Ethereum, because that means you now have a local Ganache, a local blockchain running on your computer. You'll notice that every time you close and open Ganache, there is going to be a new set of addresses with new balances, a new mnemonic, new everything. So just take note of that. It's a temporary blockchain that refreshes every time you close it. But now I can call Truffle migrate, and we're going to do the same thing again, compile my contracts, and look, this time it actually works because this time I have Ganache running. My blockchain is live. And remember, it's a local blockchain, which means it's just running on my computer. No one else can see it. Here, you'll notice we also have a new account address being used because we closed and reopened Ganache, so we got a whole bunch of new addresses. Awesome. Okay, so that is how you can migrate a contract. If you make a change to your contract and then you want to remigrate it, then you may have to do truffle migrate -- reset or even reset all, because otherwise the changes might not get updated. So just take note, if you make a change and then want to migrate again, but you're not seeing anything being properly updated, then just add the reset flag. Okay, so then you can run that again, and this will just reset all the migrations. All right, so we have been able to write a deployment script and then migrate our contracts, which means we have put our contracts onto our local blockchain. One thing that is important from all this data for our project is the contract address. We're going to save this contract address because we're going to put this to use in our project. This contract address is how you can refer to a specific contract on a local blockchain. So we're going to save that because it's going to come in handy shortly. Coming up next, now that we have built, compiled, and migrated our smart contract, we're going to start building the front end of our website. We're going to build an HTML file, and we're going to connect to Metamask and be able to interact with our smart contract via the website. So join me in our next lecture.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.